In this video, we're going to do a little demystifying of the IBM Counter Fraud Management, or ICFM, system. Now, the purpose of the Counter Fraud Management system is to detect and manage the lifecycle of fraud. Now, the detection will happen here in the analyze step, and we will use computer predictive modeling. So there's a computer essentially doing the intelligence work here, but then we want to vet those results and check the results by using human intelligence. So the computer does what it does best in step 3, and then we have humans do what they do best in step 5. So now let's go through each of the steps, and we'll begin with the ingestion step. What happens here is that you, as a customer, may have various sources of data, and these are typically multi-terabyte, we're talking big data systems, and they will be imported or ingested into Data Stage, which is an IBM product that comes with ICFM, into the CFDB, which is a DB2 product database, and it is in the DB2 CFDB that we store our data. This is not the only way to get data into the system. You could also use the ICFM GUI, and you may also have a third-party, perhaps programmatically designed system to bring in data out here as well. Now, although this isn't directly related to ingestion, it's worth noting that there is separately something here called a logical object engine, LOE, and its purpose is to take JSON that comes in, JSON that goes in, and it will return JSON back out. And it is a kind of view, a database sort of view, that has some other nice features to it that allows you to get information displayed properly in the GUI that is related specific to your industry. So internally, our databases are storing people as parties, but you may have doctors or lawyers, and it's a logical object engine that lets you grab data in the format the way you would expect as a user. And it does that using something called logical objects, and it does that through the logical object engine. And here's a very simple example of that. At the top, I'll do a trace, and at the bottom, I will issue a REST service call. But in this case, there's actually no JSON going in. This is the simplest one I can come up with. And then you can see the output here that you would expect in JSON format from the logical object engine. So that was just an aside with logical objects, but let's now move on from ingestion to our request. And the point here is that now that we have all this data in the database, we want to do an analysis on it. And that's because we're sort of looking at a needle in a haystack problem. We have tons and tons of data, but we don't know where the fraud is at. And so we're going to request an analysis of the data. There are two ways to do that. There's this way, using what's called MQ. That's IBM WebSphere MQ, which was previously called the broker. And this approach we're going to take is called service-oriented architecture, which uses messages, and that's why we have this icon here. A message is very much like an email message, except that instead of a human reading it and taking action, you'll have a computer read it and take action. The way this happens is a message will go out. You will create this message. It will go onto the CF.ANALYSIS.RESPONSE queue. This is called a queue, and this is a staging area, a place where a computer will pick it up like a human would read an email and then process it into the next stage, move it on to the next stage. This is the first approach. The second way to request information is through representational state transfer, or REST, which is more popularly known as web services, and we use HTTPS for that. Now, internally, you may see this step referred to as DAO, or Data Access Object. And here is an example of doing the analysis request, and you can see the response that we get back here, and at the top you can see the processing that was completed. And notice here this entry for Identity Insights, which we will come back to a little bit later. And that takes us through ingestion and requesting. Both of those are done. Now let's take a look at analyze. Now obviously this is the most complex of all of them. We're going to start out right here. We're going to start out with the director, which, if you're inside WebSphere Application Server, is known as the engine. And what it does, remember that message from before, well, the director picks it up and starts processing it. And the first thing it does is send it to Identity Insights, which we just saw in that previous screen of data output on the top. This is the message queue for Identity Insights, and the purpose of Identity Insights is to do what's called resolution. And resolution is the process of taking two identities, so for example, Johnny with address 1 and taking Sean with another address and saying, Sean is the Irish spelling of John, and we are seeing one identity of Johnny, one identity of Sean, and in fact, that is the same entity, and that is called resolution, and that's the purpose of ISII. ISII is also known as an analytic. It is what we are using to determine the machine learning as part of the analysis from a technical and mathematical standpoint. ISII saves its data in a DB2 database, which we can then query later in other analytics. From this point, we move on to the analysis flows. So at this point, the director has sent a message into our analysis flow. Analysis flow is an idea that is included in what is called content pack. It's part of what's called a context. It's essentially a way to outsource the analysis to one of these two, either IIB or EJB. The idea here, once again, is that we have a message. This message is going to go on a queue. That queue is a queue that you will designate here, and the message that goes there is in XML format here, and it's called analysis run parameters. And it gives parameters that go into this part of the flow. Now, although you could do this with EJB, it's more common to do this with IIB. IIB is the IBM integration bus, and it's also known as the orchestration layer. The idea here is that it works like a bus, a computer bus on a motherboard, which sends data from one component to another. And the components in our case are known as analytics, so that is this down here. The analytics that we're using at this stage are C&DS, so that is SPSS C&DS, and that software uses something called jobs, and the job will be transferred over to SPSS Modeler. Now, SPSS stands for the statistical package for the social sciences, and it is doing all of the math, the machine learning, the predictive analytics. Inside Modeler, you have what are called streams, and it's the streams doing the actual work. Now, from there, the message will be going into ODM, more than likely, and ODM is a system of rules. So that means if X, then Y. And ODM will take this very complex analysis and expose it through a GUI, a web page, to non-technical business users so that they can change the rules that are in use. And that's important because we are going to use something called a score, which we're going to look at in a second. ODM uses something called rule sets to determine all of those rules, the if-then statements. Also, C&DS uses something called PES or PES. Those are used to encapsulate, they contain the job and the stream. Now, designing this part by yourself is a whole lot of work. So we simplify that by providing industry use cases like AML or MPF, which is anti-money laundering, or medical provider fraud, or auto fraud. And we will get you started very quickly with one of these. Now, notice that an ODM rule may in fact come back into IIB, and then as a result of the score be pushed back into another ODM rule set, and these are exposed as web services. And that takes us to the score down here. So the purpose of running C&DS, ODM, and all these other analytics is to provide a score. And this is known as an assessment result. And you can see that we have this score here of 63. You'll have a name, a focal object reference, a description, a context, and a value. The value, first of all, the context refers to what kind of thing it is. Is it anti-money laundering? It's sort of the industry use case. It's the where this is being used. The value is what's called a banded assessment. So you'll have high, medium, and low, and a score, say, between 60 and 80 may be high, and anything above that's very high, and other values would be underneath that. You also have something called properties, and in the properties you may have a priority and a severity, for example, and those are shown to you through the GUI through what's called assessment actions. Now, once all of that has been processed, we're now in the assessment results. There'll be another message that gets put onto, in this case, the CF.ANALYSIS.RESPONSE queue, and that message will make its way back into the director's analysis flow in a message called the analysis run details, and that is also XML. From that point, we have now gone back into the director and essentially finished up with the analyze step, and we now move in, or just about, into the 4th step, because at this point we need to update the database with the assessment results, and these are the 3 tables involved in doing that. Notice that they are indeed going into the CFDB like before. Also notice that kind of the purpose of the director is to create a case, or if not create, then update or merge a case. Cases are also known as folios and also called alerts. And that takes us from the persist step into the final step, which is the workflow step. This is where humans become involved. And you'll notice we have triage analyst, investigator, supervisor, and administrator. The point here is that once this case has been created, it will be put into an analyst's or some person's inbox. And those inboxes are triage, investigations, referred, closed, undefined, and you can add more to the system. This is happening through something called the actions framework. And the actions framework has a state and a task portion or parts to them. A state transition will go from, say, triage to investigations and referred to closed. And a task in the actions framework is something like exporting or printing. Now, the reason you have the state transition is because when a triage analyst logs in, he or she would see triage. But this is the human portion who may look at the analytics coming back and say, this looks an awful lot like fraud, but I'm not entirely sure. So what I'm going to do is forward or move that do a straight state transition into the investigator's inbox. And the investigator can go in and look and see, is this really fraud or not? And then, of course, depending on how it's set up, the investigator may do a similar step and refer that onto the supervisor, which would be, for example, here. Now, if in the case of a legal battle, or there's some legal portion to this, the closed condition here may be where these investigations end up as part of the discovery process in a case, an ongoing pending investigation, for example. And then lastly, you have an administrator. These are known as roles, actually all of these, and the administrator has access to much of the system, much of these 5 steps. Now, let me give you a very quick demo. Let me log in. And I'll choose investigator. And then notice this is what you'll see. You have the score here. You have this is an alert or folio, also called a case. Here are the different in baskets you can choose from. And then here in this called the hamburger menu, you can select the in baskets from a list. That is an overview of the IBM Counter Fraud Management System. I hope that went some ways to demystifying the system.